My name is Li Xiahui from Computer Programming Section 4. I'm going to present the project of my computer programming. So, for the introduction, in this project, we are required to write a C program to solve simple fluid mechanics problem. So, the program must include 4 for loops and 2 functions. And the fluid mechanics problem chosen is related to the boundary layer of the tube. And the outcome of the problem is to determine the Reynolds number and use the Reynolds number to determine the boundary layer thickness, uh, displacement thickness, as well as the momentum thickness. So next, uh, we move to the problem statement. So the figure below shows the uh, problem which include the fluid flow through a tube, and the conditions are given as follows. The density of the fluid is varied from 997 to 1000, and with the increment of 1. And the diameter of tube is varied from 0.5 meter to 0.8 meter with an increment of 0.1 meter. And the velocity of the fluid is varied from 0.5 to 1.6 and with increment of 0.5. Then the length of the tube is varied from 1 meter to 4 meter and with the increment of 1 meter. And the dynamic viscosity of the fluid is remain constant, which is 9.8 times 10 to the power of -4. So from this problem, we are going to determine the Reynolds number and use the Reynolds number to determine the boundary layer thickness, displacement thickness, and momentum thickness for all conditions and all parameters. So we will move to the objective part. So the objective of this project is to write a C program to solve a related fluid mechanics problem with 4 loops and 2 functions. And as well as the objective is to identify the Reynolds number by changing the parameter such as density, diameter, and velocity. Next, the objectives of this project is also to determine the boundary layer thickness, displacement thickness, and momentum thickness based on the Reynolds number calculated. And uh, to observe the relationship of density, diameter, and velocity with respect to Reynolds number. After that, we can also determine the effect of length of the plate to boundary layer thickness, displacement thickness, and momentum thickness. So next is the methodology. Uh, the figure below shows the program that I write. Uh, from the program, we can see that there are total 3 functions, which are the function B, function E, and the main function. So for the main function, there are total 3 for loops in main function. The 3 for loops, we are going to vary the density, velocity, and diameter. And then the Reynolds number will be calculated based on the 3 parameter above. So after display all the parameter which are the density, velocity, diameter, and Reynolds number, we will move to the and we will jump to the function D. The function D use simple if and else statement uh, where the Reynolds number is smaller than a specific value, then it will display laminar type of boundary layer. Otherwise, it will display turbulent type of boundary layer. After that, we will jump to the function E, which has one for loop and one if-else statement. The for loop is to vary the length of the pipe, and the if-else statement is to determine the suitable equation for the boundary layer thickness, displacement thickness, and momentum thickness. So next we will move to the flow chart of this program. Figure below shows the flow chart of the program. As we can see, the flow chart is start, then we will have to specify the parameter that we are going to use. Then we will start to enter the for loop. There are total 3 for loops in this flowchart. Then after that we will jump to the next function. Then we will have the separate flowchart, and then after finish the function function D, then we will jump to the function E. So next we will move to the result of this program. So the Reynolds number of the fluid flow can be determined by using the formula given as Reynolds number equal to density times velocity times diameter and divide by the dynamic viscosity. So if the Reynolds number is smaller than 5 times 10 to the power of 5, then the type of boundary layer is laminar. Otherwise, the type of boundary layer is turbulent. So the table below shows the formula for laminar and turbulent type of boundary layer thickness, displacement thickness, as well as the momentum thickness. So next, this is the results that show in the C program. As you can see from the figure, it involves a lot of results because we vary a lot of conditions and parameters. Therefore, if we didn't use the C program to solve the problem, it will very time consuming and very difficult to be solved. So if we use C program to solve this problem, we can reduce the time consumed as well as we reduce the work and the steps involved. So next, for the conclusion part, it is much easier to solve the related engineering problem with C program, which involve many conditions and parameters. By using the C program to solve the related problems, we can reduce the time consuming and reduce the work involved. So based on the results obtained, when the density of the fluid and the velocity of the fluid and the diameter of the pipe increases, the Reynolds number also increases. And from the Reynolds number, then the thickness of the boundary layer, displacement thickness, and the momentum thickness are calculated. Then we can observe that the larger the Reynolds number, the thinner the thickness of boundary layer, and the displacement thickness and momentum thickness also will be thinner when the Reynolds number increases. So I think that's all from me. Thank you.